Hi everyone, welcome back to the channel. Well, today we'll try to see about the Mann-Kendall train test by using Python. This segment is basically occurred due to the fact that many requests has been given for me in order to do this test by using the Python. Previously, in other videos, you can basically find out I have done one tutorial on how we can make a Mann-Kendall train test using R programming. But some of the guys has now wanted me to just prepare certain insight or tutorial on Mann-Kendall train test using Python. So today we will see how we can use the Mann-Kendall train test to analyze the trend of the hydrological data or the meteorological data. So for our today's lesson, we'll see about Mann-Kendall train test using Python for a sample rainfall data. So without further ado, let's go to the work directly. Well, I'm here on my Jupytor notebook that I can edit my code. So as usual, first let me change the title. The title should have to be Mann-Kendall trained test. Mann-Kendall train test Python. So first we have to install the necessary libraries. That has to be very important for us to work on Mann-Kendall train test. So just %pip install, write the libraries. Pandas is one of the libraries which can be used for analysis of the data frame. Plotlib for just to do some plottings. Mann-Kendall. This is a library that can be used to work for Mann-Kendall trained analysis. OpenPy, PyExcel, which can be used to analyze the Excel file in order to open it and see what's going on within it. So I think that's enough for now, and then run it. Shift plus enter. So now it is basically installing the necessary libraries, but since I have already installed it, I may not need to install these libraries, but for the sake of showing you, it is now installing. So let's wait a while. Libraries now has been installed. So you can see here, we start the kernel to use the updated package. So you have to go to kernel, click it, and then restart the kernel. So it simply incorporates the updated package. So let me say insert, restart. Well, now import the libraries which are needed. Import pandas svd, import numpy as np, import matplotlib.pyplot as PLT to visualize the data. Import Mann-Kendall as MK. Then These are, I think, the ones that we will try to use for our analysis. If you want to just plot some linear regressions line, you can import SciPy or install SciPy. From that SciPy, you can solve the linear regressor. So for now, it's enough. Run it. Now let me read the CSV file, which is rainfall data for me. Let me go to the folder where the rainfall data is found. Here, right click, copy as paths, and then let me say the file path. The file path equals to Ctrl+V and reverse it. So this is the place or the position where you can find our data, rainfall data. So now let me give data frame as df td dot read the CSV file. If it is Excel, you can say it Excel, then the file path. Then print df, or you can say df. So you can see here in this data, you can see there's a date from 2020 up to 2022, which is, now bear in mind, whenever you are doing the trend analysis, at least you need to have more than 30 years of data without any missing information, right? So this is, since this is a cycle for showing you, it might not be that much necessary to have that much amount of data. So I have here 3 data. This is just a sample, just to show you how the Mann-Kendall trend test can be done. But for if you are doing some serious research or analysis, at least you need to have 30 years or more than of that of the data, right? So you can just visualize how the data looks like. There's the date, the index adds numbers, the station ID, the station name, Basel Airport, rainfall in millimeter, duration, hours, and in millimeter per hour. So these are basically the rainfall or sample rainfall data in daily basis from 2020 up to 2022, having 1096 rows of, which is almost 39 or not more than that of months of data. So now, after visualizing the data, what we can do is we have to make sure that there is no any missing data information. So make sure the missing data information is found or not, right? So df dot is null, right? That's all. If you run it, so you can see there is no missing data for each and every column that you can see here. But to make it more specific, let me say print the missing rainfall data counts is, just to make it more logical, from the data frame, let me extract the rainfall in millimeter, this one. Ctrl+C or copy it, then paste here. Then now let me close the bracket, then run. Now you can see the missing rainfall data count is 0. So you do not need to make some filling of the missing data, so your data is clean. Now let's extract date and rainfall. Extract the date and rainfall. So df date, since there's a date column here, you see in a small letter, that equals to what? PD dot, I want to change into the datetime format. The date is not in datetime format, so using the pandas library, I want to change this into datetime format. So PD dot to datetime df Control plus C, let me here put here Control plus V, and then close the bracket, right? Now let me say the date equals this extracted and change the data frame. Now onwards, whenever we are just referring the date, we are referring the date that has been changed into the datetime format. And rainfall is df, let me extract rainfall here, which is in millimeter. So copy this one, Control plus C, and then paste it. Then close the bracket. No. So now I have the date and rainfall, which is extracted from the data frame that you can see here in the original format. So now you can run it. So after this, let's plot the time series data. First, let's visualize and plot the data, right? The rainfall data or the time series data. So PLT, which is referring the matplotlib.pyplot library, dot figure, our area where we can put our figure has to have its own size. So this fixed size is equals to what? Most of the time 12 by 6 is recommended, or you can change it as you want. You can change it 10 by 6, 20 by 10, whatever you like, based on the graph or the plot that you want. PLT dot plots. Now let me plot the x and the y axis. The x axis has to be date and the y axis has to be rainfall, right? That means this date is the x axis, this rainfall is the y axis, right? X and y. So at some edges, or at the point where there is a deflection or the change of the data or the plots of the data, let me put some markers, right? Marker is equals to, let me put star, or there are many markers that you can choose. And the color has to be any color you want. For now I choose blue, since it is rainfall. It's better to be or symbolized by the blue color. The line style, you can choose the line style. Let me put the broken line, or you can use a solid line, right? that the line widths might be 3 millimeter. Let me put it 2. Then I want to have a label within the graph. This label has to be saying the daily rainfall data. Daily rainfall time series data. Right. Now let me customize again the graph. The title has to be given plt.title, right? Daily rainfall time series data, right? That's, you can give the font size you can give, since it's the title, let me put it 40. And the font weight has to be bold, right? Bold. And now what has to be labeled on the x and the y axis? So plt.x label, x label. In the x label there's a date. Let me put date with font size 12 is enough, I think. And again the y-axis label. In the y-axis, let me put rainfall, right? Let me say rainfall in millimeter, right? In millimeter. It's more informative. Then the font size should have to be equal with that of the X label, 12, right? If I want to have a grid, plt.grid, the plot, I can say true. If not, you don't have to incorporate the plt.grid. The legend, plt.legend, let me provide a legend with the location where I want to put the legend, upper right or upper left. Let me say upper right, or lower right, lower left, upper right, upper left. You can choose where you want to put the legend, which is saying daily rain. Now let's show plt.show and run the code. Now you can see here, this is the x-axis of the date, and here you have the rainfall in millimeter daily basis. So the daily rainfall time series data as a title, and the legend here is daily rainfall. So this is not that much visible, and it's congested. Since it's a daily rainfall, and then the plot would have been like this. So let's change this plot to have a better visualization into the monthly basis. So in order to do that, we have to resample the daily to monthly. If you want to see how we can resample the daily to monthly, seasonal, or any other format, or yearly, you can see there is other videos that I have done to see the resampling of daily data into other formats. So let me first, in order to resample, let me first define the data I have. Let me change df equals to what? pd.read csv that you have read already. File path, comma, and first date it's is equals to date and comma index column is equals to what? Date. I'm just making the date as an index here, right? Because here in this path, it's simply calling where the data is found by reading the CSV file by using the pandas data frame with the pandas library, and the index is this numbers 0 up to 1095. But now I'm making the date as index column because it is very important to resample it into the monthly format. So let me say the monthly sum. I want to have the total monthly rainfall data, and let me say the monthly sum df, and the data is rainfall, right? Rainfall millimeter underscore millimeter, or you can copy it from the data frame dot resample into monthly me, and then dot sum. Now what I did is I'm just changing the daily format of the rainfall data into the monthly sum or the total monthly rainfall data. So rainfall, let me change the name, monthly is equals to monthly dot sum, or let me copy this one, copy Ctrl plus C, Ctrl plus V. Now you can print it in order to visualize the monthly rainfall or the total monthly rainfall. Ctrl plus C, let me say Ctrl plus V. Now run the code so you can see it. Now the date format is basically showing at the months of each year in each year, so it is basically changing into the monthly data by using the resampling technique. So you can easily resample it. So we can plot this one again, the monthly data, plot the monthly time series, right? In order to do that, first we have to make it as an index. The monthly data or the rainfall monthly has to be as an index. Let me say, where is it? Copy this one, Ctrl plus C, then Ctrl plus V, dot index. Let me give a name, months, plus random name. Months has to be taken as an index. Now we have to plot the graph. So in order to do that, let me copy this one, or you can basically follow the same procedure. Copy and paste. You can customize it. You can customize these things. So the main thing that has to be customized is in the x-axis. I want to plot months, right? And just on the x-axis. On the y-axis, rainfall monthly, right? Monthly. Rainfall monthly. Instead of daily rainfall, change it into monthly rainfall. Instead of daily here again, we can change it monthly rainfall time series data. You can put it as a date the same. Here again, you can say total monthly rainfall in millimeter, and everything might be as it is. So you can run it. So you can easily visualize how the pattern looks like, right? At some point, it has a high monthly rainfall data around 2021 of month 6, right? The 6 months. Well, this is basically how we can visualize the data in monthly or daily format. So now let's do the Mann-Kendall trend test, the main topic here. Mann-Kendall trend test analysis, right? So let me say the Mann-Kendall trend test for daily data, the Mann-Kendall result for daily data is equals to Mann-Kendall is basically designated as MK dot original test. That means the original data without changing its format, and rainfall. That means this rainfall is basically, you can go back to the point where we have been given the name rainfall here. You can see rainfall means within the data frame we have extracted the rainfall in millimeter, the daily format. So now let me print, copy this one, Ctrl plus C, then Ctrl plus V, and now run the code. So the Mann-Kendall trend test shows there is no trend with the p-value. The p-value has to be less than, whenever it is less than 0.05, and whenever it is greater than 0.05, you can say it's decreasing or increasing, significant or non-significant, I mean. And also the z value, which is less than 0 and 0, is increasing and decreasing trend. So the variance here, the slope, the intercept, and the legs has been given here, the tau. So based on these parameters, you can decide whether the trend is increasing or decreasing. But it doesn't mean necessarily there is no trend, right? What you have to understand is, since the data is very short, I mean for 3 years, due to the lack of enough data, it might say the trend is not trend. So you have to make sure that your data has to have enough amount of data that can be very essential for trend analysis. The same, so you can do it, for example, let me say copy this one, Ctrl plus C, Ctrl plus V, then you can do for monthly. We have resampled it into the monthly format, and then you can do it for monthly, rainfall monthly, and then let me change this one, monthly. So run it. So the Mann-Kendall trend test has shown that also not trend, but the p-value, the z value, and the tau are basically showing some difference, right? Certain amount of difference has been seen in this analysis. So this is a way how you can do the Mann-Kendall trend test by using the time series data you have in your hand. Based on the necessity, you can simply interpret the data. So You can say there is another way that you can just interpret the data. That means, let me say interpretation of the data. Let me say I'm the alpha or the significance level 0.05. So using if condition, let me write if this thing is happen, say it's this. If this thing happen, then unless say it's this. So I think you have some Python background on how we can write if conditions. If the Mann-Kendall result of the daily base, let me say, copy this one. If the Mann-Kendall result of the daily base dot p value is less than alpha or 0.05, less than alpha, right? Infer print trend is statistically significant, right? The trend is statistically significant unless it's insignificant, right? Statistically significant. Or let me add another if again control plus v, let me say the Mann-Kendall results of daily dot trend, right? Dot trend is equals to increasing, it says increasing, you have to print the significant increase range. Print rainfall shows the daily rainfall, let me say the daily rainfall data shows a significant increasing trend, let me say trend, right? Else there's also another function that we can say else or else if. Let me say else, since I have another argument, I want to say else if. Control plus v, the Mann-Kendall trend test dot trend, right? Dot trend is equals to decreasing. It says decreasing. Well, this else if has to be not else if. Instead of else, we have to change into el. El if means else if. Then print rainfall shows let me copy this one. Control plus C and control plus V. Instead of increasing here, decreasing. The answer decreasing, right? The final argument else print no statistical significant trend detected. Trend is detected. Now let me run the code. There is a syntax error. The trend is statistically significant. Where is it? Print. Okay, here I need to have a bracket. It has to be closed. Now run it. So after running, as you can see here, no statistical significant trend is detected. So this is a way how you can do the trend analysis. I hope you have got this very helpful and important. So we will see other topics in the future. Goodbye for today.